Hi, and welcome to Internet of Brains seminar. I suppose some of you are here with some transhumanistic hopes, some others with some privacy concerns, or some other with just like some curiosity about this weird term, Internet of Brains. The seminar is divided in two parts, and the goal is to give a clear understanding of the concept and a practical example of Internet of Brain implementation. The first part will be more about the concept, the context, and in order to have a frame, let's say a knowledge framework to understand the thing. And the second part is about a live demo of Internet of Brains. My name is Matteo, and I'm a philosopher as well as a programmer and a media activist, and I have passion towards brain-computer interface and neural interfaces since 2013, when I started looking into the news and following what was going on the neuroscience side of it and on the technological side. And I wrote a few articles about it, and also I made up a website called mindholocaust.is that is about the privacy concern part of the story. And also I co-founded, together with friends, a community called MindLab Space that is located in Malmö, Sweden. And we play with the brain-computer interface and neurotech technologies and software towards the democratization of this technology. And hopefully we'll meet there one of these days. It's not the first time I'm giving a lecture or a seminar about the brain-computer interfaces. Actually, this is part of a series of seminars that is following a thread within this topic. The first one was in Barcelona a few years ago. It was called From Neuroweapon to Social Neurogadgets. DARPA promotes the market. And it was about this technological transfer from the military sector towards the commercial sector and mass consumer use of brain-computer interfaces. I gave another lecture in this series called Microcontroller Technology, the Consumer Choice, that was following the first one, and it was this time about the products that are already available on the market at a cheap price for the mass consumer person to use brain-computer interfaces and implement brain-computer interfaces applications. Internet of Brains is not a new concept and is not so difficult to understand. It's about Internet of Things. We are all familiar about Internet of Things, the world of things that are interconnected over internet, and the brain-computer interface. Like we can think about our brains as one of the things, one of the terminals of the network that is out there. It's not mad science. It's something that is a really proved concept. We can look already in 2015 what Matt Robb was saying about. Matt Robb is the CEO of Qualcomm, that is a big company that take care of networking infrastructure. And he was saying that if you look at 3G and 5G data as a service for your eyes and a vision service, perhaps 6G will go beyond the head-mounted display and will introduce a neural interface. So he was already forecasting that one of the services to come, like the 6G network for mobile phones, will enable brain-computer interface application and Internet of Brain itself. He was not speaking like that just because he had a dream about it. In that period, 2013, DARPA was leading and calling a representative from the giant IT companies to discuss the term Internet of Brains in terms of feasibility. The question was about, do we have the capacity in order to deliver to the public space something like Internet of Brains. That was already, I would say, a technological achievement or a forecast in the military sector. And doing so, we are assisting towards, we are in front of a technological transfer that comes from the military sector to the public sector. Well, all this started in fact with the militaries at DARPA. JCR Licklider was a director at DARPA, and he envisioned Internet as we know it today. His idea of Internet was about an intergalactic network of things and people. He wrote a book called Man-Computer Symbiosis, and he was explaining this technological revolution in terms of not as artificial intelligence taking over the world, but as a symbiosis between man and machines. Again, we have to remember that the mindset of these people are really warfare oriented. He was in charge of the Command and Control program at DARPA, and he was an expert of behavioral science. And he forecast that Internet as well as brain-computer interface would have been a strategic tool in the right hand. And doing so, he advocated for the project Internet to start, and at the same time, the brain-computer interfaces as a complementary side of the Internet project started to take place, basically at the same time and in the same places where Internet was for the first time experimented and implemented. So if we look at this graph, we can track a parallelism between Internet and Internet of Brain as a project, as an implementation of a concept. And the gray area just are saying that the project is secret, and we can see that Internet, as we know it today, was a secret project at DARPA from the beginning of the 60s till the beginning of the 90s, when it started to be a public thing. The brain-computer interface, Internet of Brain thing, as well, is a secret project that was started at the beginning of the 70s, and involving the academic sector as well as the commercial sector, like the RAND Corporation. And today is about to be deployed, or I would say transferred to the public sector, as Internet was during the beginning of the 90s. This is not a graph I made up myself. I just is a consequence of the news that I read. So we can see, we can read about the brain-computer interface project, research grant from DARPA that was installed at the University of California, Los Angeles, already in the end of the 60s. Coincidentally, University of California, Los Angeles served as the first node of the Advanced Research Project Agency Network, ARPANET. That is the first chapter of Internet as we know it today. Just like to highlight the concept that the brain-computer interface and Internet of Brains is just one of the two sides of the Internet project and the Internet of Things project. As is so, and it was envisioned by Licklider, the DARPA director at the beginning of the 60s. We can read about this vision in his book, Man-Computer Symbiosis. This is obviously not the cover of the book, and we have to remember that he had quite of military mindset, and also I would say a patriarchate mindset. It doesn't say human-computer symbiosis. Anyway, in the picture, Johnny Vidal, Jacques Vidal, sorry, he was the inventor of the term brain-computer interfaces, and he was the first that received money from DARPA to work on this technology at the University of California, Los Angeles. Then we can jump to the last decades, the first decades of the new millennia. In 2009, we can already read in the fiscal budget of DARPA for the year 2010 a project called Silent Talk, who was financed with 4 million in order to reach user-to-user communication on the battlefield, and without the use of vocalized speech. So it was a practical application of synthetic telepathy and the advancement of neurotechnologies to the battlefield. The program had 3 major goals, and one was to attempt and identify the patterns of the brain signals that would map unique words of the natural language, to ensure that those patterns were generically, let's say, usable among different users, and so in order to avoid personal machine learning training for every user that had to use this device. And third, the third goal was to construct a feasible pre-prototype. I mean, something that could work on field, that would decode the brain signals and transmit let's say the message from one soldier to another one on the battlefield, on a short distance. Again, I say it again, without vocalizing or using the vocalized speech. So DARPA is building here a synthetic telepathy device in 2009, and the one that received the money at that time was the Carnegie Mellon University, that also made a public publication of the result that they achieved with these grant funds that they received. But we can look at this later. For the moment, I would like to call your attention to the fact that at the head of the DARPA program of the DARPA agency there was Regina Dagan, that has been the first woman leading the DARPA agency from 2009 till 2012, and she was the one that was in charge while the program Silent Talk was developed. Regina Dagan, I wanted to highlight her presence at the head of DARPA, because if we wait 5 years, in 2017, we can spot her on the Facebook F8 conference. That is the PR conference that takes place in San Francisco, if I'm correct, and where she was talking about the project Building 8, a secret project at Facebook, where she had the pleasure to be the director of. So that was about mind-reading devices. Facebook is implementing a mind-reading device to allow users to publish a post on Facebook just by thinking about it. And the project Building 8 is that nowadays has become the Reality Lab. And also Regina Dagan abandoned the project a few years ago. But just to say that after DARPA, she had a short passage at Google HATAP, another secret project whom or reach is still quite unknown. And then she moved to Facebook to drive and to lead a mind-reading project called Building 8, and nowadays is included in the Reality Lab initiative. While she was at DARPA, Regina Dagan also founded two new offices. One about technological knowledge transfer with the office Adaptive Execution Office, and another one inside the Information Innovation Office, E2O, that was about technological assessment. So while she was at DARPA, she also took care of implanting 2 new, I would say, facilities that could take care of technological transfer. That is when we basically move the knowledge about the technology from one sector of the society or from one company to another one or another sector, in this case from the military to the commercial world. And technological assessment is another thing, is the discipline that make possible to define and to define how a technology should be used by the user. So let's say internet could have been seen as a big library at the beginning, and for example in the vision of Tim Berners-Lee. But then we know that today internet is more about a market of services, online services, and the fact that the use of internet has shifted from a public library towards a market of services is something that can be driven by something that is called technological assessment. Now, let's go back to the Project Silent Talk, and when DARPA had grant research for the Mergicano University of Pittsburgh, the hero here is Marcel Just. He was able to build a system that could translate the semantic perception of words into text using computer algorithms. And so basically this also in collaboration with the Intel Advanced Research Lab that is in Pittsburgh as well, and is led, at that time was led by David Tannhauser, that was again a former director at DARPA. And so we can see like a clear synergy here between the academic world and the private sector with Intel and his Advanced Research Lab, in order that a synergy that strive to achieve a technological goal. In this case, the Project Silent Talk on the military side, and on the public side, the research that they have conducted was published as in order to demonstrate the fact that he was able to detect words in the people's mind and just translate it into text, just using computer algorithms. So it's a big achievement for what concern the public acknowledgement of synthetic telepathy here, because for the first time Project Silent Talk was made public in this research that was published. And but we can also forecast it's not only about synthetic telepathy, brain-computer interfaces, and have many applications. One could be gaming, for example. In this slide, we can see a product called NextMind that was launched at the end of 2019. The first prototype are available in June 2020 from a private company founded between France and Finland, and basically the goal here for this product is to read the visual cortex that is behind our skull, and to detect the signal of the visual cortex and translate into commands. So if we focus into something, we can trigger commands on that thing. In this case, the player is playing video games, virtual reality video games, and when he focuses on the image of these aliens, then it fires also a laser beam that kills them. So it could be like video gaming in the future coming up for brain-computer interface application quite soon. The problem has always been the interface. We imagine the brain-computer interface or neural interfaces as a big headset full of cables, but for example already in 2013 a private company and quite successful, Epoch, made a product called Epoch Emotive, and they really reduced the number of sensors that were needed, and they delivered really amazing, I would say, user experiences through brain-computer interfaces, through an interface that was not so invasive as we could imagine before. it is expected the interface to be even more reduced to a simple pair of earbuds. For example, by a company called Neurable, they just received a round of 4 million investment to deliver such a small interface in probably 3 to 5 years. There is also but different technology can be applied here. For example, Facebook is working for its device on proton collider technologies. Another company that's called Open Water is working on sensors that are made of light, so light sensor that can be used easily, for example, under a cuff or a hat. But most probably the future will be about ultrasounds because it's a really promising technology. There are a lot of results that are coming from this technology, both in reading, censoring the mind, but also in writing, stimulating the mind. And he has a resolution of 1 neuron, so we can basically decide which neuron to stimulate or which neuron to read. While with AGG is more imprecise, and it has a really low resolution from this point of view. So we can imagine that in the future, in a really near future, we might have an ultrasound chip, BCI, installed in our mobile phone, and that our mind might be always online as today it is with Facebook or Google Maps or GPS location. And this is what probably will happen soon. And yes, let's see, for example, how DARPA is looking at this. This video was published in 2018 during a conference that was led by DARPA when the agency had to present the result that the agency had about new technologies. We can see in this video that the brain of the people really looks like and have the same color as a mobile device, like a tablet and mobile phones. And the brain, as the mobile phones, as the tablets, are connected to this world of big data-driven applications, and everything is completely transparent to them and to the information and technology industry. I think they have quite a real clear vision, and this vision involves one of the concepts that involves is for sure transparency and brain-computer interfaces and Internet of Brain. Already today, we can play with the lab streaming layer ourselves at home with a little computer, personal computer, and a cheap brain user interface. Lab streaming layer is a protocol, and together with a series of compiled library for C++, Java, and other languages like Python, for example, that allow how to discover a source of brain signals over the network, and so to pipe and connect a source to another that is happening on a terminal location together with computational unit that is on another address over internet and the network. Lab streaming layer, again, it's an open source protocol. I discovered recently that the implementation of it was again financed through the military, and no surprise here. And the thing is that it's easy to use, and it opens a really easy approach. It facilitates the implementation of brain-computer interfaces and brain internet. We can imagine user cases with this, using this LSL protocol that puts together brain sensoring, but also heartbeat sensing and other biosensor like muscle biosensor, together with virtual reality or augmented reality, or with laptops and mobile phones, and why not gaming consoles, in order to deliver to the user experience that can vary from practical application, but also to home entertainment ones. So in a user case scenario, we can forecast, we can have like brain-computer interface headset that connects to Bluetooth, via Bluetooth through our mobile phone, where there is an application that is live streaming layer enabled, and that application of our mobile phone will start streaming our brain signal towards internet to reach a computational unit, maybe on the cloud, that will auto-discover the source and then deliver probably feature extraction. I mean, it will give meaning to the brain signals and will translate those meanings into commands and in order to control devices. One application could be remote medical analysis, but we can also forecast multiplayer online driven by brain-computer interfaces in a short time. I invite you to go online and take a look at the live streaming layer protocol. It's really well documented, and as I said, it's open source and it's really easy to use. And in order to prove this, I would like to bring on a live demo to you. And I wrote in Python, and it's really easy. It's just show the basic concept, and I mean, there's no. I think anybody with some basic programming skills can implement an Internet of Brain application, and just by using the LSL protocol and some Python scripting, for example. So this is the script we will go through, and as you see, it's really short. What we do is that we import first the Python library, PyLSL, that basically is the library ported to LSL library ported to Python. And then what we do is that on the main routine, we look for an LSL stream of type EEG. We can specify the type here. And then once the stream inlet have found the stream, we can connect then the stream to our script and use the data and manipulate the data and deliver our application based on the data driven by the data that are incoming. In this case, in this super simple case, we'll just list the name of the stream and some of its characteristics. So let's imagine that we have brain signal source here. In this case is a simulated one, but let's suppose I have a brain-computer interface here on my head, and that the brain-computer interface is streamed to my laptop. And then what we are doing here is that we take the brain signals and then we stream it over the local area network using the LSL protocol. And on the other side of the story, we just detect the signal and we listen for its characteristics. So over the same network, we have found that there is a EEG stream, and that has 8 channels whose sample rate is 250 Hertz, and so 250 sample per second. And we just list it here. We can look how it looks like with this script receiving data. It's really a simple script. It does the same, so it just imports the Python LSL library, and then once it has resolved the stream, it just prints on screen the data samples. Where is it? Here we are. And here it is. These are the raw samples in microvolts that are coming from the source, the EEG source over the network, streamed over the protocol inside the tunnel of live streaming layer protocol. That is, of course, based on IP, TCP/IP protocol. So it's an application, it's an application layer implementation. And yeah, on the other side of the pipe, we just read those signals to analyze them and to extract features, like for example words, what I'm thinking, or if I'm thinking to move something, if I will or remember something, or if I'm looking at something that I recognize. All the brain activities have a meaning, at least most of them, and we can detect them and translate them into a command trigger that then can be a driver for applications. Well, we can imagine that this script could stay on a cloud solution, and we could deliver, instead of just a print screen, we could deliver a video game, and that would enable us for a multi-player game that is driven by our mind and our brain signals instead of a keyboard. Well, I think it's pretty impressive and quite inspiring, and it's open up for a lot of games to play. I mean, we like to code, and we like to play with these technologies, and so as I said at the beginning, we have founded a community in Malmo, and we meet at the makerspace in a makerspace called Stappen, that is a cultural public space. Everybody can participate. We do organize meetups where we meet. We provide one each other suggestions and tips about how to use brain-computer interfaces and use the lab streaming layer protocol and other implementation. And yeah, we entertain, we enjoy ourselves, maybe with just neurofeedback application. But what we are aiming to do is to build an open source framework that might integrate, that might facilitate the development for brain-computer interface application and Internet of Brain application. We are working together also with the University of Malmo, Internet of Things and Person Lab. And yeah, I think we are looking for promising things to come and to build as well. Just enjoy us, and I hope we'll meet soon. Thanks so much. On the QR code you can scan the MindLab web space. You will find there a link to our website and where you can join our community and find more information about what we're doing, and I hope to see you soon. That was it. Thanks so much, and see you online with your brain and your mind. Hey, bye bye.